Okay, cool. So let me know a little bit about your relationship with math. Is math a subject that's difficult for you? Is it one that's easier? So how do you normally feel about it?
It's kind of in between. Like at first, like if it's something that I haven't been experienced with, then I wouldn't really understand it. But then once I get used to it, then I'll get better at it. And yeah.
Okay, perfect. So have you taken pre-algebra yet, or are you skipping right now?
I don't. I think I have. I'm not quite
You have?
sure
Okay.
though.
So what we're going to do today is actually just get started with the first unit of Algebra 1 and just do a little lesson together, kind of see what you know going in. Yeah, if you decide to enroll in classes, what we'll do is we'll start with a review of pre-algebra and then go right into the first unit of Algebra 1. Okay? Today is just kind of a demo of how I teach to see if you feel like you work well with me. And yeah, so let me know as we're going on if you have any questions or if anything doesn't make sense, okay?
Okay.
Okay, I'm going to go ahead and share the screen. So the first unit of Algebra 1 is on algebraic expressions and variables. So the key difference between algebra and between math before is that in algebra, we don't always know what a term represents. So for example, in elementary school math and even in some middle school math, we're working with numbers and fractions and, known quantities. Once we get into algebra, a lot of times we'll have, equations or expressions where we don't know what everything represents and we have to figure that out. So first, an expression refers to basically a number and variable sentence. There's no equal sign, no greater than sign. It's just a set of terms. So this is an example of an expression. Now, like I said, the key difference between an expression and an equation is that an equation tells us something in terms of equality. It has an equal sign or a greater than sign or a less than sign, something like that, comparing two quantities. An expression doesn't compare any quantities, it's just the numbers themselves. Now, in any expression, there are terms. The terms are separated by addition and subtraction signs. So in this case, we would have three terms. Can you try to identify what those terms are? And again, terms are the specific quantities that we add or subtract. So a good idea is to split it into what's separated by an addition sign. So what's one of the terms that you see there in any order?
4n.
Yeah, 4n. So the terms are 4n, like you said, 8 and 8. These are separated by addition and subtraction signs. Does that make sense?
Yeah.
Okay, let's do one more like that where you identify the number and what the terms are. Okay, so tell me how many terms there are and what they are. So let me type an example out for you. Okay, so tell me how many terms there are and what they are. And you can either write your answer on the screen, say it verbally, or type it in the chat, whatever's best for you.
Would it be 4 terms? Or is...
Well, let's look a bit closer at that. So here's everything that's split with a plus or a minus sign. This has 3 terms.
Yeah. Sorry. And then say what the terms are?
So what are the terms? Yeah.
6xb, 17y, and 12.
Very good. Perfect. Okay, so the next idea to work with is like terms. Like terms are terms with the same variable raised to the same power. So basically, you could think of it as they're holding up the same sign. Like, for example, if we had 7x squared minus 2x squared, do you see how those are kind of like holding up the same sign? They're telling us the same thing, x squared. So we can combine like terms. you have 7x squared and 2x squared, which would come out to 5x squared. Does that make sense?
Yeah.
Now, on the other hand, we might have unlike terms that are not the same. So for example, it might be something as simple as, let's say we had 2xy minus 3x squared y. Those aren't the same because that's a different power. That's not raised to the same power. Does that make sense?
Yeah.
Okay. So now let's do a couple examples. I'll give you a term and you can give me a like term. Tell me something that has the same variables with the same powers. Okay. And like I said, you can either annotate or send your answers in the chat, up to you. Or tell me what your answer is. And is everything making sense so far?
Yeah.
Perfect. Okay, so why don't you go ahead and come up with a like term for number 1, something that is the same term.
It like something like, I guess, like 2x to the power of 2, squared y.
Perfect,
Right?
yeah.
Or like to the power.
That's a like term. Very good job. Perfect. Okay, let's go on from there. Okay, so for each of these, what we're going to do is go through, tell the number of terms, and then we also have to go over, do you remember the definitions of coefficient and constant, or is that something that you don't remember?
I know that we've talked about them, but I don't remember the
So coefficients are, let me type that out, the numbers in front of the variables. So it's what we multiply the variables by. Constants, however, are just numbers all alone with no variables. Constants are non-variable numbers. So for example, let's look at the first one together. So in this case, we would have the number of terms is 2. The coefficients, well, we just have 6. And the constants, 3. Does that make sense?
Yeah.
Okay. Do you want to try that for the next one?
Sure.
Perfect.
The number of terms are 2.
So the number of terms is what?
2. And then the coefficients is 6. And then the
6, very good.
Oh.
That was very good, yeah. And what's the constant?
3.
So in this case, the constant would actually be -3.
Oh, yeah.
Does that make sense?
Mm-hmm.
Okay, good. Try number 3. So this one is not a trick question, but keep in mind what that negative would represent in terms of the coefficient, okay? But try that for number 3. So again, just tell me the number of terms and then the coefficients and the constants.
The number of terms are 3. The coefficients are, is it 0.2 and 8?
Very good job.
And then
But you forgot 1. So you got 2 of the coefficients right, but there's 1 more. So if we have -y, how many y's are there? Well, there's -1. That negative, keep in mind whenever you're working in algebra, if you see just a letter by itself, we know that the coefficient is 1. If we see a letter being subtracted by itself, we would know the coefficient would be -1. Does it make sense?
Yeah.
If it doesn't make sense, try to think of it in terms of this. If you're subtracting a y, it's getting negative. It's going less. Does it make sense?
Yeah.
And there are no constants for this one, so you can go on to the last one, and then we'll move on.
The number of terms is 1, and the coefficient is 1/2.
Very good job. Perfect. Okay, let's go on. Well, before we move on, do you have any questions, or is everything making sense so far?
No, everything makes sense, yeah.
Perfect. Okay, so now we're going to work on combining like terms. So do you remember what I was explaining about like terms, how they're the same, they have the same variables and the same exponents?
Yeah.
So what we're going to want to do, whenever we get an expression, we want it to be simplified. We want it in its simplest form, just so that it makes sense as to what they're asking us. So simplifying basically means that you can't combine any more like terms. You've already combined everything. It's like putting everyone into their own groups. Does that make sense?
Yeah.
So let's look at number 1 and go through our steps. So we're going to search for like terms. So everything that has an X, we can go through and underline. So there's everything with an X. When we combine them, we would have 4 plus 5, which makes 9, plus that one more X makes 10X. Now let's work with our numbers. Now we have plus 7 and plus 2. Well, what's 7 plus 2? We would have 9. So 10X plus 9. Does that make sense, those steps that I just took?
Yeah.
Okay, do you want to try number 2 on your own before we can go into some more complex ones?
Sure.
Perfect.
Would you want me to say it out loud?
You can just solve them, and then if you get it wrong, we can talk through it, but you can just solve it and then let me know.
Okay. All right, I'm done.
Okay, what did you get?
I got -3n plus 9.
Very good job. Perfect. Okay, we'll do one more sort of easy one like that, then we can go into some longer problems. Actually, we can just finish up the page. Why don't you try 3 and number 4?
All right.
Okay, and you're doing really well so far. A lot of these topics can be pretty tricky to wrap your mind around at first because it's just so different from pre-algebra and everything before, but yeah, good job.
Thank you.
Are you doing okay with number 3 or do you need some help?
Oh no, I got it. Yeah.
Okay.
I also did number 4, so yeah. I'm ready though. Yeah.
Could you repeat that, please?
I'm ready. Yeah.
Okay. And what's the answer?
Negative 7b plus 2n minus 4.
Are you still there?
Can you hear me?
Hello? Yeah, I can hear you. Sorry, the audio cut out for a moment. Negative what?
Negative 7b plus 2n minus 4.
Very good job. Okay, and let's just try number 4, then we can move on.
All right.
We won't spend too much longer on combining like terms. We'll just do a couple problems with more complex variables. Then we'll go on to multiplying in order to simplify expressions.
All right. All right. I'm ready.
Okay.
I got 4g plus 7h minus 5.
Now, positive 4 or negative 4?
Positive 4. Wait.
So if we have negative 7 plus 3, that would be negative 4g. Does that make sense?
Yeah, I didn't see the negative on accident. Whoops.
That's okay. Okay, well, good job. I'm just going to pull up your next worksheet. We'll just do like 3 or 4 more combining like terms problems because you've been doing so well with it, and then we can move on.
All right.
Okay, I'm going to go ahead and share the screen again. That should be loaded up in a minute or two. Okay. So let's try 27 through 30. So this just adds the additional step of multiplying, distributing before. So when you distribute, what you're going to want to do is multiply that by both terms. So we'll work through number 27 together. So you would have negative 10, because negative 10 times 1. And then if we have negative 10 times negative 9, that would become positive 90, right, with that x right there. Does that make sense, that first distribution?
Yeah.
Okay. And then from there, we'd have plus 6x minus 60. Why don't you finish off simplifying that and then try the rest on your own?
All right. Do you want me to say what I got for like the simplified version of 27, or do you
Yeah,
want
so
me
just tell me your answer. Yeah, you can just tell me your answer once it's simplified. You don't have to say all the other steps. So what would you get once you simplified number 27?
I got negative 70 plus 96x.
Very good job. Okay, you can go on to 28. So just follow those same steps we did for 27, distribute, and then combine like terms. And then, like I said, you can just give me your final answer. You don't have to say all of this.
Ah,
Are you doing okay with number 28, or do you need a bit of help?
I'm good, thank you though.
Are you doing okay, or do you need a bit of help?
I'm good, thank you though.
Okay.
Alright, I think I got it.
Okay, let's hear.
I got 8n plus 26.
Try again. So if we have negative 10 and then positive 2, that would be negative 8n. Does that make sense?
Oh.
So if we have 5 times negative 2, we would get negative 10n. 2 times n would be 2n. Negative 10 plus 2 would be negative 8. Does that make sense?
Oh yeah.
Okay, perfect. But yeah, the rest of that was good. You can go on to number 29. We'll just finish up this page, and we're going to switch topics a bit.
Okay. I have 29 now.
Okay, let's hear.
Negative 25b minus 20.
Again, close, but if we have negative 30, oh, you
Mhm.
said minus 20? I'm sorry, I thought you said minus 40. Perfect. Good job. You can go on to number 30.
Okay. I got number 30 now.
Okay, let's hear.
Negative 71n minus 29.
Very good, perfect. Okay, so now we're gonna just pause for a second, and I kind of want to evaluate how you're doing with exponents. So, do you remember any of the like basic exponent rules? Well, just to start pretty simple, do you remember how to evaluate exponent expressions, like 7 to the 4th, for example? Because exponents are very important for our next topic.
Yeah.
So, okay, so do you want to try to evaluate that? Then we can do some work with exponents and variables.
Alright.
And you can use a calculator for this.
Alright. Do you want me to write it out in expanded form or
So
just like
this should be given in simplified form. So in expanded form, it would be 7 times 7 times 7 times 7, and just go ahead and write it in its simplified form, okay? Oh, I'm sorry. I didn't realize I was muted. After this, we'll be done with numbers. We can do 1 or 2 problems with variables and exponents, and then we'll be done for the day.
I got 2,401. Like so.
Perfect. Okay, so it's pretty similar when we work with variable exponents. So before I explain, try to write this out in expanded form. What do you think that would look like?
That would be like x times x times x times x, and then times y times y.
Good. So, actually, we are just about out of time. So if you end up deciding to sign up for classes, what we'll do is we'll move on to the next topic from this first unit of Algebra 1, which is just going to be working with exponents and working with variable expressions. So in these last couple minutes, do you have any questions, any concerns?
Nothing. I mean, no.